All right, you guys, today I'm doing a little review for quiz 7, and our problem today, this big first problem, is just to help you guys see the connections that we're making when we write proofs. So first up, I'm saying cite the reason the given sides or angles are congruent, and then complete the statement. So here in A, I'm saying that these two pairs of corresponding sides are congruent. How do I link up that third pair? So I'm linking something back up to itself, and anytime I have the same side or the same angle, we just see it more often with sides, we're using the reflexive property because that is the same side for both triangles. Has to be congruent with itself. So my reason here would be the reflexive property of congruence. Okay, and if I name it as segment ON, so let's say that I look at the triangle on the left. So here I would say if I read it from O to N, it's in between the single and triple tick mark sides, O to N, right? And then N is between the 2 and 3 tick mark sides. So over here, it happens to be in the same order. It would read as O to N. So in between the single and triple tick mark sides, O to N, in between the double and triple, just like that. So it reads as O to N for both triangles. Okay, one other thing that I can see is that where ON is a line of symmetry. I can see that this triangle would reflect over ON onto itself over here. Okay, for B, here, I have two pairs of sides marked as well. And I see again that I have that common side, that shared side, triple tick mark right here. So here again, that is the same side for both triangles. This is the reflexive property of congruence. And if I name it FR, so let's say that I look at this triangle on the left. F right here is in between the single and triple tick mark sides. But over for my second one, that would be R. R is in between my single and triple tick mark sides. So when I read it as F to R for this triangle, it ends up being R to F for this one. So let me do that with my fingers, kind of like this. They're linking up like that. So FR is to RF. Okay, and then if I picture how is this triangle moving into this position, I can see that it's rotating 180 degrees. So if I picture where K is, let me plant my pencil down like that. Where does K rotate into? K would rotate into O's position 180 degrees. So I can picture my triangle here rotating 180 into this position right here. So we're seeing some of those transformations within our triangle congruence unit. Okay, next up here, I'm focusing on angle PRE. So this one right in there. So really, when I see parallels, I know to emphasize them. And then here is my transversal. So if I'm trying to link up angle PRE, I would link it up to its alternate interior angle right here. And then I would have my two congruent angles here and here. So if I name the first one PRE, the second one would be AER. Okay, one other thing I want to point out, because I was really making this lecture here as we head into writing proofs. So this first one then here, A, right, my triangles would then, once I make that last connection, be congruent by side, 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 and same over here. Okay, the one that I just did right here, once I connect those alternate interior angles, Then I have side, angle, side. So the angle is sandwiched in between This is side, angle, side. Okay, my next one here, I have parallels as well. So let me emphasize those. And now I'm trying to link up angle RBA. So this angle, right, I'm trying to link it up to another angle. So if I picture my transversal right here, then I can link up my corresponding angles right here. Here and here. Give it a double tick mark since I already used that single notation. So here I have angle, side, angle. It's the side that's in between. That's how I would prove these triangles are congruent. Okay, and if I finish my statement, RBA, that would sync to DIB. So my reason here, this one was corresponding angles postulate. Right, I can picture this angle sliding into this position. And then over here, this one was the alternate interior angles theorem. Okay, next up. So here in E, I'm giving you this notation that says CR is perpendicular to AR. So let's say that I marked that then with a right angle notation. I know that CRE is right. Right? I know that because of the perpendicular relationship right here. I also know that MA is perpendicular to RA. So these are perpendicular, which makes a right angle right here as well. All right, so how did I get there? I'm just building off of what it means to be perpendicular. So this would be definition of perpendicular. Right? If I'm told that I have perpendicular pathways, that creates right angles. And then if I want to say that CRE is congruent to MAE, then I would just use definition of right. If I wrote a sentence, that would be fine. So I can just say right angles are congruent. I will always take that as well. Okay, so then which combo would I have? Right, they're both right triangles. I see hypotenuse to hypotenuse. I see leg to leg. So this would be HL. All right, next one here. I'm trying to link up angle BAR, right? BAR. So I can link it up to its vertical angle here to here. So if I call the first one BAR, the next one would be NAI. My reason would have been the vertical angles theorem. Okay, and if I call the, let's see, if I, I need to give my reason, lastly. So I know that I'm connecting those angles because they're vertical angles. And then do I have enough information to say that the triangles are congruent? I would, because I have side, angle, side. All right, next up. Point G is the midpoint of FO. So if we're told that G is the midpoint right here, what would that lead us towards? If I know that a point is a midpoint, it's the middle point, right? It's going to split that larger segment into two congruent parts. So I can give a double tick mark here and here. So I know that FG is congruent to OG. And if I wanted to say that my triangles are congruent, what combo do I have? I have side, angle, side. Okay, next one here, AM bisects FMR, this angle right here. So if AM bisects FMR, if I bisect an angle, that splits it into two congruent parts just like that. So if I name that first angle FMA, that second angle will be RMA. And if I wanted to say that my triangles are congruent, I have angle, side, angle. All right, let me just add back in what my reason is for G and H. So for G, I can make this statement because that's what it means to be a midpoint. So definition of midpoint. And over here, I can make that connection because of that language bisect. So definition of bisect. All right, lastly, here I wanted to show how we can build off of isosceles triangles. So here in I, right, with the angles that are marked, which two triangles am I trying to connect? Right, with what's marked, I must be trying to connect this triangle here to this triangle right over here. So if I'm telling you that this triangle down below is isosceles, how would that help me? So if I know that that triangle right there is isosceles, I know that I have two congruent sides and I have two congruent angles. So it's a matter of which one's going to help me here. And my sides are what would help me here. Here and here, because I'm trying to prove that these two triangles are congruent. So now I would have angle, angle, side as my combination. All right, let me just write my reason for connecting these two sides. So if we know the triangle is isosceles, then we have two congruent sides. Okay, and if I call one of those sides HT, the other one would be HR. Okay, and then by building off that last little detail here, I now have angle, angle, side. All right, my last one here. Okay, which triangles am I trying to link up? Well, with what's marked, it looks like I'm trying to link up these bigger triangles here. So let me draw them out separately. So whenever I'm going after the bigger triangles, it helps me to pull them apart and visualize them as two separate entities. So here is CTR, and here is ATR. So what I already know is that this angle is congruent to this angle, and that this side is congruent to this side. And then I'm told that this triangle here, again, is isosceles. So what is it I want to pull from that triangle? Do I want to pull information about sides or angles? So if I know that this side is congruent to this side, I know that's true, but it doesn't help me connect to any side of a triangle because I need this full side here, here. Okay, so knowing that this part and this part here match, again, doesn't give me a full side of a triangle. So the sides aren't going to help me, but the angles will. So I know that if a triangle is isosceles, I have two base angles that are congruent here and here. So for this triangle right here, that angle would be right here. And for this triangle here, that angle would be right here. So if I say ATR, ATR, or read it here, ATR, that links to CRT. Okay, and my reason would be, well, if my triangle is isosceles, then I have two congruent angles. Okay, and now that I have everything marked, my triangles would be congruent because of angle, angle, side. So this whole exercise, this whole practice problem number 1, is really just helping you build off of certain language to make another connection, whether it's a pair of sides or angles, and making sure that you can link up those corresponding parts, sides or angles, appropriately. All right, let's flip it over and look at the back. All right, so for the first one, I'm saying let's solve for each indicated measure. So in A, I'm telling you that we have an isosceles triangle. A is the vertex angle. So let's start there. Let's draw an isosceles triangle. I'm not trying to draw it to scale. All right, so here's my isosceles triangle. A is the vertex angle, so A has to be in between my two congruent sides. So my other two angles have to be V and N, and it doesn't matter where I put them. So I'll draw them like this. So here's my triangle VAN. A is the vertex angle. V and N would be my base angles. And here I'm telling you that the ratio of base angle to vertex angle is 2 to 5. So let me write that. I know that base to vertex angle is 2 to 5. So I know that whatever these measures are, base to vertex, they're going to be in a ratio of 2 to 5. Okay, so I need to know, well, what is the multiplier that I'm putting on that ratio so that my angle measures together will all add to 180. So I'm going to write my ratio instead as 2x to 5x. All right, so my base angles, I'm going to mark with a 2x. Base angles are congruent. And then the vertex angle, 5x. Okay, so now if I add all of these up, I have 9 x's, all equal to 180. Divide each side by 9, and x is 20. Plug back in that 20. So here I would get 40 and 40. And 5 times 20 would be 100. So the measure of V would be 40 degrees. And if I just check that, if I have a ratio of 40 to 100, if I divided both of those numbers by 20, it would get me back to a 2 to 5 ratio. So I'm just confirming that I still have a 2 to 5 ratio. All right, next up. So here I'm solving for x and I'm solving for y. So right now I see my tick marks here and here. So I know that my two sides are congruent. So let me build an equation. I know that x minus 1 equals the square root of x plus 5. So I see it's a radical equation, right? I see the square root and I see a variable underneath it. So to unlock that square root, I need to square both sides. And in doing so, on the left, when I square a binomial, x minus 1 times itself, I have to FOIL it out. So right now I have x minus 1 times itself equal to x plus 5. So if I FOIL this out, here's my first, here's my outer, here's my inner, and here's my last. So if I clean that up, I have x squared minus 2x plus 1, all equal to x plus 5. So I see it's a quadratic equation. I know that I need it to be equal to 0 so I can factor and solve. So I'm going to take away x and take away 5. So x squared minus 3x minus 4 equals 0. So now I'm looking for two numbers that multiply to a negative 4 that add to a negative 3. So I have x minus 4 times x plus 1. So when I set each factor equal to 0 and I solve, I get that x equals 4 and x equals -1. So if I plug back in, the 4, so if I plug a 4 back in, 4 minus 1 would get me 3. Square root of 4 plus 5, square root of 9 would also get me 3. So this one works. X is 4. Right, it gives me a side length of 3. Let's try the -1. So if I plug in a -1, -1 minus 1 would be -2. Well, I know right now that that's not going to work. I cannot have a side length that is negative. So the only solution that will work here is an x value of 4. But it's totally possible that I would have more than one solution. We've seen that play out before. All right, then I want to get to y. So if my sides are congruent, right, if it's isosceles, then my base angles, they are congruent too. So now I can say that y squared plus 2y equals -6y minus 15. And now, again, it's a quadratic equation. I'm going to pull everything to one side. So I'm going to add 6y and add 15. So y squared plus 8y plus 15 equals 0. So I have my quadratic equation, I have everything set equal to 0, and now I'm going to solve by factoring. So what multiplies to 15 that adds to 8? So it has to be 5 and 3. So y plus 5 times y plus 3 all equal to 0. So when I solve, I get y equals -5, y equals -3. So let's check that -5 first by plugging back in. So -5. So -5 squared is 25. And then plus 2 times -5 would be -10. That would give me 15 degrees here. Over here, -6 times -5 would be +30. 30 minus 15 would give me 15 degrees over here. So this one works. So y can be -5. Let's see if there's a second option. So if y is -3, -3 squared is 9. Okay, plus 2 times -3 would be -6. 9 minus 6 is 3 degrees. It's small, but it's still possible. All right, then over here, -6 times -3 would be 18. 18 minus 15 would also be 3. So this one also works. Y could also be -3. So I'm going to say -5 and -3. The angle measures that are produced are still positive and greater than 0, less than 180. All right, I want to close out with 2 proofs. So here I'm saying prove the triangles are congruent using one of these combinations that works. So remember that with this information, we have a rigid, unique triangle, so that any second triangle with the same information, it would match that first one perfectly, and that will hold true of any of these 5 combinations. Okay, so here I'm giving you a couple of givens. So that should help you make some connections. So let's start with that first one. SN is parallel to OW. Given. Okay, so how do I build off of that? So here I would likely use my colored pencils. So if I use my colored pencils together, let me just see where I tucked them. I might have to use different color. Okay, so if I use here my purple, here and here. So if those are parallel, and then here is my transversal, okay, those parallels are going to lead me to my alternate interior angles. So right here in 2, I can say that angle SNW is going to be congruent to OWN. That is the alternate interior angles theorem. Okay, and now I'm kind of at a dead end. Okay, I have another given, so let's pick up on that. So I can say next that angle 1 is congruent to angle 2. Here and here. Okay, but those angles are outside of my triangles. I want to get inside. Oh, and I need to give it a double tick mark as well. Okay, I need to get inside of my triangles. So what I know right now is that these are congruent. I know that these angles would be supplementary because they form a linear pair, and so would these angles right here. And if I can establish that these angles are congruent, and then here I have two pairs of supplementary angles, then I can connect 3 and 4. I know that the supplements of congruent angles, they have to be congruent too. So let me get to that. First, I just have to flesh out that 1 and 3 are supplementary. And I know that 2 and 4 are supplementary as well. Linear pair property. So again, if I know that these angles are congruent, these form a linear pair, so do these. They have to be supplementary. Then I can connect 3 and 4. And as I say it, I mark it. So that would be the congruent supplements theorem. Okay, the supplements of congruent angles, they also have to be congruent. So I'm linking up 3 and 4. So now what I have two pairs of corresponding angles that are congruent. I need a pair of sides. What's the most common pair of sides that we use? That's shared side. We use this information right there. Reflexive property. So here if I say NW for one of the triangles, NW, let me say I'm talking about the one on top. So let me just block out of view, a little post-it here, the other one. Okay, so if I'm looking at NW, N to W, single tick mark to unmarked angle. So if I look at the other triangle then, that would be W to N. So here the order flip-flops. I can also see it back here in my statement. So NW right here will correspond to WN right there. Regardless, it's the reflexive property. Okay, and now that I have my two pairs of corresponding angles and my one pair of corresponding sides, I can say that my triangles are congruent. So triangle SNW would connect to OWN. I have two angles and the non-included side. So this would be angle, angle, side. All right, I have one more proof and then we'll call it a day. All right, so here I've seen this diagram. I've seen it a couple of times before. And I know that sometimes we're connecting these two smaller triangles, and sometimes we're connecting these two larger triangles. So I want to just keep my eye on what I need to prove. Here it says WHE. So right here, I'm looking at this triangle here. So I must be trying to link it up to this triangle over here. So I don't need to redraw my picture. When I'm looking at these big triangles, and they have those overlapping parts, that's when I like to split it apart. You can always split something apart. That's not going to hurt you. I just don't need that here because I think it's easy to see. All right, so first I'm told that this triangle here is isosceles. So triangle EHL is isosceles with base EL. Given. All right, so if this is isosceles right here, where is that going to lead me? Do I want to use the congruent sides or the congruent angles? What's going to help me connect to that yellow triangle? Well, the sides. The sides are going to help me, not the angles here. So I can say then that this side is congruent to this side. So segment HE would be congruent to HL. If a triangle is isosceles, then it has two congruent sides. All right, so we have a pair of sides linked up. Okay, then we have another given. So I'll tuck it in right here. WH is congruent to AH. Given. Okay, and now I need to look in my picture for one other connection, and I see those vertical angles here and here. So angle WHE is congruent to AHL. So vertical angles theorem. All right, so now I have two pairs of corresponding sides, and I have their included angles as well. So this would be an example of side angle side. So I can reach my conclusion that triangle WHE is congruent to AHL. Side angle side. All right, that's all I have for our review today. Have a good rest of your day.